Hi guys, thank you for tuning in. Today I'll be talking about a series RL circuit connected across an AC supply and explain the derivations for current, power and drawing the power plot. The method to deriving the above parameters is going to be the same like that was done earlier for a resistor and an inductor. You can refer the previous videos by following the link in the description. To begin with, take a resistor and an inductor. Put them in series across AC supply so that the same current flows through both the elements. The source voltage is given by V equal to Vm sin of omega t, and the AC current flowing is denoted by letter I. When current passes through a resistor, it generates a voltage VR, and when it passes through an inductor, it generates a voltage VL. We have to find an equation for this current. For this, we take the help of the phasor diagram. The phasor diagram for a series RL circuit has already been described in my previous videos. Do check out the links for reference. Now from the diagram we can see that the equation for voltage can be written as V equal to VR plus J times VL. To find the magnitude of this voltage, using Pythagoras theorem in the right-handed triangle, you get V square equal to VR square plus VL square. Let's take a quick recap of how phasor and the equation for current in a pure resistive and a pure inductive circuit are written. You can see that in a pure resistor, voltage and current are in phase, while in a pure inductor, they are 90 degrees apart. Now when you combine both the elements together in a circuit, the current and the voltage will have a phase difference somewhere between 0 and 90 degrees. We don't know the value yet, so we can call it as some angle phi, whose value will be determined in the coming stages. With this assumption, we can write the equation for current I as I equal to Im sin of omega t minus phi. To find the magnitude of this current, consider the right-handed triangle and the relation V square equal to VR square plus VL square. Substitute V as IR from Ohm's law and simplify to get the equation for current I. The current can be written as V divided by root over of R square plus XL square. Substitute V as Vm sin of omega t. It is seen that when sine reaches its maximum value, voltage reaches its maximum value, and so will the current. The value for Im is given as Vm divided by root over of R square plus XL square, where the term root over of R square plus XL square is called as impedance of the circuit. To compute the value for phi, consider the triangle again, and if you calculate tan phi, it will equate to VL upon VR. Substituting VR and VL as IR and IXL, the relation will simplify to XL upon R. Hence, the phase angle phi is given as tan inverse of XL upon R. So, the final value for current in a series RL circuit is given as Vm divided by root over of R square plus XL square into sine of omega t minus tan inverse of XL upon R. Now that we have the voltage and current equations, we can draw the waveforms. Following the same sequence, draw the voltage waveform first. For comparison, draw current waveforms of resistor as well as inductor. In case of a pure resistor, current is in phase, so wave starts from 0. Talking of inductor, it lags by 90 degrees, hence it starts 90 degrees after voltage wave. For RL, the phase angle is phi, determined by the values of XL and R. So it will be some value between 0 and 90 degrees. So the current wave will look like that shown in the red color. With voltage and current equations and the plots, it is possible to derive the power equation and draw the power plot as well. For instantaneous power Pi, which is equal to V into I, substitute the values and simplify using the trigonometric identities. You will get P equal to Vm Im by 2 cos phi minus cos of 2 omega t minus phi. The terms may be separated and written as Vm Im by 2 cos phi minus Vm Im by 2 cos of 2 omega t minus phi. Next, to find the average power, integrate the equation over the working cycle, that is from 0 to 2 pi, and divide it by the total time interval. The integration is carried out with respect to omega t. The first part of the equation has no omega t, so all terms are constant. Integration will give Vi cos phi by 2, while the second term has cos of omega t in it, and we know that the average value of cos from 0 to 2 pi is 0. So the second part of the equation will return a value 0. The 2 in the denominator may be written as root 2 into root 2. Hence, the equation simplifies to Vm by root 2 into Im by root 2, which can also be written as Vrms into Irms into cos phi. To plot the average power, draw the voltage and current waveforms as has been done in the earlier videos. If you multiply both, you will see that the resultant curve has a pattern as shown. But unlike in the case of a pure inductor, the negative halves are not large enough to cancel out the positive halves. So there will be some power loss, but it depends on the values of R and L in the series circuit. Do let me know if you have any suggestions for topics by dropping in your comments. Like, share and subscribe to never miss an update from Explanator, where every solution has a simple explanation.